This is the fourth section of chapter 1, and in this section we're going to be looking at the stepping stone method. Now the stepping stone method is the last step in finding an optimal solution to these transportation costs. So we've done the north red corner method, that was the first section, that gives us an initial solution. Then we calculate the shadow costs, so that was the second section that we went through. After we've calculated the shadow cost, we then calculate the improvement indices. And what we found is that if all of the improvement indices are all positive, so we have no negatives in our improvement indices, then we've found an optimal solution, and then our steps end like in this flowchart and we finish here. If we do have negative improvement indices, so they're not equal to negatives, or actually we do have negatives, so I suppose I should put equal negative. So we've got at least one or more negative improvement indices. We then use the stepping stone method, and this is going to allow us to improve our costs, minimize our costs. And then stepping stone method we're going to go through in a moment. Then we're going to calculate our improved costs after doing the stepping stone method. Now we need to check whether these improved costs are in fact an optimal solution. So we need to go back, calculate the shadow costs, calculate the improvement indices, and if we've got no negatives, we know we've got an optimal solution. If we've still got negative improvement indices, then we carry out the stepping stone method again, calculate improved costs and so on. So this arrow shows that we've got iteration here, and we could be iterating 2, 3 or more times until we get an optimal solution, and we end here. Okay, so let's look at this stepping stone method. So the first thing we need to do is use the entering cell, and that is the cell that had the most negative improvement index. So we've just done this. The one that has the most negative improvement index, you'll know from the previous section, we called the entering cell. And we use this as an increasing cell. Now basically what we're going to do is that cell that has the most negative improvement index, we're going to put theta in that cell. Now what we then need to do is to rebalance the other cells, that is rebalancing the transportation costs, by moving to an adjacent horizontal or vertical cell. This is what's called a stepping stone method. So you're basically going to be moving across or moving down, never moving diagonally, to rebalance the supply and demand of the cells. Now when we go through an example, it'll make a lot more sense than just reading through a list of instructions. Then we choose the maximum value for theta, this increasing cell, that leaves no negative cells, and then a cell with a value of 0 becomes the exiting cell. So a cell has entered, a cell has exited. We then calculate our improved costs, and a quick way to calculate our new costs, our new improved costs, is that's going to be equal to our previous costs that we got before. That may be the initial solution if we're doing the first iteration here, plus the improvement index times by theta, so this value of theta that we've chosen here. And once we've completed that, we then need to decide, is this new cost an optimal solution? So we need to calculate the shadow cost and improvement index. So every time you calculate the stepping stone method and you calculate the improved costs, you do need to do the shadow cost and improvement index again before we can end, because we need to show, are these new costs optimal or not. Example 10. In example 2, the table of costs were here as shown in this table here, and the initial solution using the stepping stone method was here in this table here, and that gave us a cost of £9,010. And what we want to do is obtain an improved solution and find the improved cost. Now if you look back at that example where we worked out the improvement indices, it was this cell here, BW, that had the most negative improvement index, and that was negative 130. So BW now becomes what we call the entering cell, And that means in this cell here, we're going to enter theta. Okay, now I'm going to need to do a bit of working in that table. So I'm just basically going to copy this table over here. I've got a bit more space. Now in this new table, I don't need the totals of the stock and demand, just the actual units of stock and demand here in the middle part of the table. And here you can see my entering cell BW, and I've put theta here. And the next step is to rebalance the cells so that the totals remain the same as they were before. So for example, if I put theta here and I want to keep the total as 11, I need to put 11 minus theta here. Now what you'll see is basically if I start at this cell, I need to move across to this cell, and then across to this one, down to this one. We step stone across the grid. We go across or down, left or right, normally left like this, to go from our entering cell to the end. That's why it's called a stepping stone method. So you're never going to go diagonally. You're never going to jump across cells. You're always going to be going from cell to cell across in this stepping stone fashion. So as I said, we want to keep the totals balanced. I know that the total of this column is 11. So that means I need to write 11 minus theta. That keeps this total as 11. Now, if I look at this top row, the total of that top row needs to be 14. So at the moment, this is unbalanced. So to rebalance it, I'm going to put plus theta here. So you can see that keeps the total as 14. Going down, looking at the total of this X column, that should be 15. Now at the moment it's 15 plus theta. So I need to put minus theta here. That keeps it balanced. So now this total is 15. Then I go across like this, look at what this total should be. That should be 16. So at the moment, that total is 16. So we don't require any further balancing. So we end up basically just stopping here, and we sort of ended this stepping stone method. And you should always check that the totals still agree with the demand and stock that we had originally. The next thing we need to do is to find the largest value of theta that's going to keep all of these cells positive, and that's going to be 11. So I can subtract 11 from this. That will make it 0. So we can make cells 0, but we can't make them negative. So for example, I couldn't have theta as 12 because I'd end up with negative here. So the largest value that I can have for theta is 11. So now I'm going to replace all the thetas with 11 and then work out what the new values in the cells are. So the 11 minus 11, that now becomes 0. 3 plus 11, I'm going to have 14 in that cell. And the 12 minus 11, I'm going to have 1 in that cell. And not forgetting the theta itself, that becomes 11. Now, the cell that contains a 0 is called the exiting cell because that now has a value of 0. So we can get rid of that. And now using these new values, we can work out the transportation costs, and we should have an improved solution to the one that we had before. So I've highlighted the cells of costs here that match up with the table, and now I'm going to work out what this new improved cost is. So I've got, let's do it here, improved cost. And if we've done it correctly, it should be a lower cost than the £9,010. So we've got 11 units at £190, plus 14 units at £110, plus 1 unit at £250, plus 4 units at £150, plus 10 units of £190, plus another 10 units at a cost of £120. And that gives us a total cost of 7,580. So I can see that's an improved cost on the previous one. Now there is a way that we can check to see whether this is right, because our new cost, our new improved cost, is always equal to the previous cost plus the improvement index times by the value that we had for theta. And if we do that calculation, we do indeed see that we get the same result, 7580. So this is a useful check to make sure that we've carried out these stepping stone steps correctly. So in this example here, example 11, we're now going to find an optimal solution for that previous example that we did. So just a reminder of the steps that we need to follow. And they're going to be the new shadow costs, the new improvement indices, and then the stepping stone method. So we're going to start with the shadow costs. So from our last sort of table here, I'm going to highlight the cells which we're looking for the costs for. So that's AX, BW, BX, BY, and CY and CZ. So we just got to make sure that the pattern of cells here matches this. This is where we got to. I'm basically going to iterate and carry out another iteration of this. So remember, we start with a supply cost on the very first one at the top there of 0. So we've got 0 here. So these are my shadow costs. I haven't written the headings down, but I suppose you could put shadow cost, couldn't you? So I'm going to write them down here and along the top. Remember, we need to keep all of this balanced. So if I've got a 0 shadow cost here, then that means this one needs to be 110 to ensure that we get the same total. So I'll write down 110 above X. Moving down to the second row here, well, I know that the heading of this column here is 110, and I know I need to get 250, a total of 250 here, which means that I need to write a heading here of 140. So 140 will go at the side here. I think what I'll do is I'll write those numbers in, and that'll be helpful. It's easier to refer to it in that table there. So I'll just put that in there. 190, 120, yeah. So we've got to the point where we've said, right, okay, so those two add up to 250. Now, if I've got 190 there and I've got 140, that means the shadow cost there needs to be 50 above the W. We'll carry on here. That means that this shadow cost here needs to be 10 at the top there, so I'll put 10 there. Now, if that's 10 and I want 190 there, that means that here I need to put 180. So we're basically just creating the headings from what the numbers are in the cells. And here we need to be careful. Remember, shadow cost can be negative. So I've got 180 there. I need negative 60 above Z, so negative 60. Next step is to find the improvement indices. And remember, to find the improvement indices, I now look at the costs of the unused cells. So let's highlight those. So it's basically going to be the opposite of those ones. So it's going to be this cell here, that's unused, so is this one. So I'm looking at the unused cells from my shadow cost table there. Next, the second column, it's the bottom value that's unused, and then the top value here that's unused, and then in the last column it's the top two cells here where they've not been used. And I take these unused costs and I subtract the shadow costs to find the new improvement indices. All right, so let's work through that. So 180 minus the shadow costs. So the only shadow cost for the 180 would be 50. So 180 minus 50 leave me with 130. Then I move down to this cell here, okay, which would be here. So it's 240 minus 50 minus also 180. That leaves 10 to go in that cell. Then we move across to this one. That would be here. So that's 270 minus 110 minus 180. That gives us negative 20. So it goes here. And then moving on, this the 130, which would be here. So 130 minus 10 minus 0. So that just leaves 120. So that goes here. And then on the last column, the 290. So 290 minus negative 60. So basically you add 60 to 190. 290. And that's going to give you 350. And then the last one down here, 280. So that's minus 60 or plus 60 minus 140. And that will give us 200. So those are our new improvement indices. So I'll just label that as new improvement indices. Now we know this is not an optimal solution because we have a negative improvement indice. When they're all positive, we know it's optimal. So we need to carry on. We know that we're going to have to do another iteration after this point. Now we know that the most negative cell gives us what we call the entering cell. So that's the negative 20, which is going to be our new entering cell. So we'll just write that down as part of our working. And then the next step is to use our stepping stone method. So we copy down our last table from here that we had at the last iteration. We copy down here, and our new entering cell is CX. So in our entering cell, we put theta. I'm going to keep this all balanced. Now this is a stepping stone method, which means we start in this cell, and I'll draw little arrows. So I'm going to move to this one to balance it. So if I'm going to balance that, and I've already got theta there, I need to change that to 1 minus theta. That balances this column. Okay, from there I'm going to step across to this cell, and I need to keep this balance. So you can see that it's not balanced, it's not the same total as it was before. We need the total to be 16. It's actually 16 minus lambda. So next to that 4, I'm going to put, sorry, not lambda, theta, 4 plus theta. That means that this column is now unbalanced. So I use my stepping stone, and I'll step to the next cell. So that needs to be 10 minus theta. 10 minus theta. And as you can see now, that rebalances this row here. So it's still balanced. We've still got the same totals as we had before in the original table. Next, we find the largest value of theta that's going to keep all of these values positive, and that's going to be a value of theta of 1. We can't go any bigger than that. We'll now work out what these new totals are here. So that cell where we had theta, that's going to be 1 minus the theta, that's going to just be 0. And actually we'll see in a moment, we'll rub out the 0, don't need a 0. And 4 plus theta, that's 5. And then 10 minus theta, 10 minus 1, that's going to be 9. Okay, so we don't need a 0 here. So I can see by carrying out the stepping stone method that where I was using BX before, BX is now 0, it's gone. So cell BX is the exiting cell, it's now gone. Exiting cell. We're now going to work out what our improved cost is. And the quick way of doing that is going to be our old cost, £7,580, plus the negative improvement index times by the value that we chose for theta here, and that will give us 560 pounds. Now you could work that out manually, so you could work out 110 times by 14 and 190 times by 11 and so on. So multiplying each of these by the costs here for each unit, but this is the quicker way of doing it. So we repeat the steps again. I'm going to highlight these cells here in my cost table here, cost matrix. So I can take these out, and the new cells that I'm going to have highlighted are going to be AX, here, BW, BY, CX, which is there, CY and CZ. And using those, I'm going to work out my shadow costs. So I'll use this table again up here and work out what my new shadow costs are. So I've put my unit costs in the table and make my first source cost 0. So I'll put that here, and then we'll keep it all balanced. So that means 110 here, and that means putting 160 here. 160 plus 110 is 270. That means to balance this 160, that means I need to put 30 at the top here. Okay, that allows me to sort of fill in this middle row now. So if I've got 30 here, that's going to mean 120 here. If I've got 120 here, that means I need to put 70 at the top there. And then finally for this one here, that means I need to put negative 40 at the top of this column. So these are my new shadow costs, third iteration. So remember, what we do is we're going to take the original costs and take away the improvement indices. Sorry, take away the shadow costs of the unused cells. So I'm going to highlight the unused cells now. Right, so let's go through these then. So 180, which would be there, subtract 70, so that's 110. 10, let's get a pen, not a highlighter. Right, what's the next cell we're going to go to is this one. So that's going to be 240 minus 160 and minus 70 as well. So we're taking away 230 basically. That leaves us with 10. Then we move to this cell here, which would be here. So 250 minus 120 minus 110. So 250 minus 230. That leaves us with 20. Then the 130 here, we're going to subtract 30. So that leaves us with 100. Then the last two, 290, which would be here. So 290 minus 40. So 290 plus 40 is 330. And then the last one, the 280, that would be here. So 280 minus 120 minus 40. So 280 minus 120, minus 120 plus 40. And that gives us a value of 200. So we'll just put that in 200. Now, we have no negative improvement indices, so we know that we found an optimal solution. So we'll just write that down. Since we have no negative improvement indices, we have found an optimal solution. We have found an optimal solution. So let's go on, use the stepping stone method and work out what this optimal solution is. Now, in fact, we don't need to use the stepping stone method again. We just use our last values here. When we work out the shadow cost and improvement indices, it's basically telling us whether our last stepping stone method gives us an optimal solution. So this one is an optimal solution. So now we can write down what that solution is. So from A to X, we're going to transport 14 units. From B to W, we're going to transport 11 units. From B to Y, we will transport 5 units. And from C to X, 1 unit. C to Y, 9 units. And last but not least, C to Z, 10 units. Example 12. The table shows the unit costs in pounds of transporting goods from each of 3 warehouses A, B and C to each of 3 supermarkets X, Y and Z. It also shows the stock at each warehouse and the demand at each supermarket. So I'll just highlight our stock and our demands. And remember, the middle part of the table is the costs. So I'll just highlight those. So we tend to use the two of these separately in our algorithms. Now it says, solve the transportation problem shown in the table. Use the northwest corner method to obtain an initial solution. You must state your shadow costs, improvement indices, stepping stone routes, theta values, entering cells and exiting cells. You must state the initial cost and the improved cost after each iteration. So we're basically you putting all of those different steps together to find an optimal solution to the transportation costs. Now, the first thing that I notice is that this cell is empty. So we do need to check that this is a balanced problem, because we may need to add a dummy column or a dummy row. So let's just check that. So we'll add these totals together and see what we get. So 13 plus 11 plus 12, well, that gives me 36. And then adding this way, yep, this also gives me 36. So this is a balanced problem. So I can put 30 there, 36 in there, and I'll just put problem is balanced. Sometimes we do get problems which are unbalanced, and then we need to add these dummies. So we need to start with the northwest corner method. So I guess we'll use this table over here to put in our supply and demand, X, Y and Z, and then we'll put the stock here, and then we'll fill in the supply and demand. So you've got 10, 13, 13 and 13, 11 and 12. Okay, so we'll start up here, northwest corner, and we'll see that this place needs 10 units. Okay, so that means that they have their demand met. The next one on, well, they can use up the 3 units of stock that are left from A. So all their stock has been used up. Y needs 13 units, so they need another 10. So we'll put 10 units there, so their supply has been met. And B, they have 1 unit left over, so we'll give that 1 unit to Z, so all of that stock is used up. Z, they need 13 units, and they can get 12 units from C, so their demand is met and all of C's stock is used up. So now using this, we can work out the initial cost, and it's going to be 10 times by, well, actually let me highlight the cells so it's nice and easy. So we're using up stock here, 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 here and here. Okay, let's rub the others out so we can just see the things that we're looking at. So 10 lots of a cost of 24 plus 3 lots at a cost of 22 plus 10 lots at a cost of 26 plus 14 lots, oh sorry, 1 lot at a cost of 14 plus 12 lots at a cost of 20, and that gives us an initial cost of £820. So I'll just write that up here, initial cost £820. So we're going to hopefully improve on that by following through our algorithm. So the next step is to calculate our shadow costs, and we'll do that in this table down here. So we have X, Y, Z, A, B, C. So we're going to write in the cost that we've used, They're the highlighted ones. So 24, 22, 26, 14 and 20. Then we start with a source cost of 0. So we want to keep the rows and the columns balanced, which means then that's going to be 24. Going across, that means that this needs to be 22. If we've got 22 here, this has to be 4 to keep this all balanced. If we have 4 here, that means we're going to have 10 at the top here. And if we've got 10 at the top there, that means we need 10 at the side. So be careful that you don't accidentally put a positive when it should be a negative. Next, we're going to calculate our improvement indices. So we'll just get the table ready for that. And we'll also transfer across our shadow costs. And remember, now we move now to the unused cells. So maybe I'll just put a cross in the cells that I've used so that I know which cells that I'm going to be using. So I've also highlighted those cells here. So let's now work out improvement indices. So at the moment I've got 0 and 10 here. I see that I've got 28 in this box here. So remember, it's going to be this cost minus the shadow indices. So it's 28 minus 10 minus 0. Just gives you 18. Then for this cell here, which is the one here that has 26. So 26 minus 24, which is 2, minus 4, leaves me with minus 2. Then this cell here got 20. So 20 minus 10, which is 10. 10 minus 24, that's going to leave me with minus 14. And then the very last one here where I've got 22. So 22 minus 22, that's 0, minus 10. So that leaves me with minus 10 here. So they're my improvement indices. So this is the part now where I'm going to do the stepping stone method. So all the bits we've done already, you already know. So this is the bit you want to just listen carefully to as we go through the stepping stone method. So first of all, we look for the cell that has the most negative improvement index, which is CX. So we're going to write down that CX is the entering cell. So part of the method did say that we need to write down what the entering cells are and exiting cells. So entering cell. And then we put theta in that cell. So we put theta here. And what I'm trying to do is improve this initial solution here, which means I need to sort of change the stock values and the demand values that I've got in here to improve on this solution. So these are the values that I use from this initial solution. So when you get to your stepping stone method, first of all, locate the cell that has the most negative improvement index, and that's this one here. In my stepping stone method matrix here, put theta in that cell, and then we go back to the stock values, the demand values that we had here in our initial solution, and we need to rebalance those. So imagine you put theta in these cells, but you don't want to change the totals of the rows and the columns. So if I put something there, then these other values need to be rebalanced to keep the totals the same. So actually, you don't need to do this, but I'm just going to put the totals here because these can't change. These are fixed. The amount of supply and demand is fixed, but where each supermarket gets its stock from can change as long as their demands are met. Now, if we have a look here, I had 10 in that cell. Now, if I were to put 10 in that cell, the total of this column is no longer 10, it's 10 plus theta. So to balance it, I put 10 minus theta. So now I keep the total the same. So notice that I've started in this cell here. This is called a stepping stone method because you must move to an adjacent cell that has a value in. Okay, so I now need to move to this cell here. So the cell that has the 3 in, like this. Okay, so just put a little green arrow to show that I'm stepping from that cell to that cell. Now put that 3 in, I now need to look at the total of this row. Now at the moment, with this theta that I've put in to make this column balance, this row doesn't add up to 13 anymore. It's actually 13 minus theta. So to keep it balanced, I put 13 plus theta. So now the total of this row is still 13. Stepping stone method, so I'm going to move to an adjacent cell, can't move diagonally, so that means I'm going to move to the cell underneath here, like this. Now this cell had 10 in it, so let me put 10 in there, and then look at the totals to see if it still balances. So let's have a look at this column, because there's nothing else in this column. So this column now adds up to 13 plus theta. So to keep it balanced, I need to put 13 minus theta, so that adds up to 13. Then I stepstone to an adjacent cell, so that's going to be this cell here. So that had 1 in it, yeah, from this table up here, from my initial solution. So we'll put 1 there. Now we'll check to see the total of this row. Total of this row is 11 minus theta, so I'm going to put plus theta. Notice how it seems to go minus theta, plus theta, and so on, alternating from plus to minus. So this now adds up to 11, and then I stepstone to the last adjacent cell, which is this one down here, 12. And to keep that balanced, this needs to be minus theta. Now if this is all done correctly, every row and column should balance. So this balances to 13, and notice that this row also balances to 12. Yeah, so that's the stepping stone method. Make your most negative improvement index theta, go back to your initial solution for your transportation of stock, not the cost, the stock, and rebalance the cells, stepping horizontally and vertically from one cell to another until you reach the last cell and the levels of stock and demand are rebalanced. Now the next thing we need to do is to choose a value for theta, this entering cell. The maximum value we can choose for this, to replace it with a number, so that none of the cells becomes negative. So some are going to become zeros, but we don't want any negatives. So the biggest I can make this is going to be 10, because these two will become negatives. These will become like 13 and 11 here. Even this will stay positive, it will stay as 2. So you can't pick any bigger value than 10. Otherwise what happens is you get negative values in those cells. So theta is going to equal 10. So that's our theta value stated here. Okay, so what I'm going to do now is to put those new values in my table here, the one I used to work out the initial costs, because I'm now going to work out an improved cost. So that theta Cx becomes 10. So this is now the entering cell. Now I've got 2 cells that became 0. I'm going to write them as 0 for the moment. This is only temporary. And then AY is 13. And then BZ is 11. And CZ is going to be 2. Now we need to choose the cell that's become 0 as the exiting cell. Now I've got a choice of 2, and it doesn't matter which one I choose. I'm just going to choose AX because it's the one in the top corner, but you could also choose BY. And if you like, you could try going through this problem and changing BY as the exiting cell, and you'll see that you'll still get the same solution either way. So I'll just put that down here because we need to state that we've chosen AX is the exiting cell. So that's the cell we're no longer going to use. We've now decided that cell CX is going to be part of our solution. So I'll take that out. Okay, so if any cell exits when it's 0, don't write it down. Okay, only the cells which you haven't chosen to exit, even if they've got zeros in. So now we're going to calculate an improved cost. So we'll do that here. Now, we know that this is not an optimal solution because, and I did mention it, but I have mentioned it before, we have negative improvement indices. So we know it's not optimal solution. So here we will calculate our improved costs. And let's do that now. So the cells that I have highlighted, so let's just change those to the ones that we're actually using. Okay, so that's going to be 13 times by 22, then 0 times by 26, plus 10 times by 20, plus 11 times by 14, plus 2 times by 20. Now that gives us an improved cost of £680. Now a quicker way of working out our improved cost is to take our previous cost, which was 820, and we add, or it's always going to be minusing, the improvement index. That's this one, that's the lowest improvement index where we chose to put theta, times by theta. So if I do 820 and then do negative 14 plus negative 14 times by theta, which was 10, so that's 820 minus 140, and that's also £680. So I went through that right at the beginning. So we take our last cost, or that we did on the first iteration, that's going to be our initial cost, and then do theta times by that, the same improvement index that we used. That's going to be a negative. Subtract that from the first cost, and then you get your improved cost. So my improved cost now, and I can see it's improved, is 680. That saves time sort of multiplying each one of these stock levels by the cost here. You'll get the same solution. So now we're going to work out the shadow costs. So the cost that we have are 22, 26, 20, 14 and 20. And we start with our source cost here of 0, which means that this cost here needs to be 22. Going down that column, that means that this needs to be 4, which means that this needs to be 10. And if that's 10, that means that this also needs to be 10. And also we need to put a 10 here. We just make sure that those totals agree. We'll put the shadow costs onto the next table here, and we'll work out our improvement indices. And this is going to be on the unused cells, so I'll put a cross in the cells that I've used here so I don't use them by mistake. So I've highlighted the unused cells in green, so I've got 24 here. So 24 minus 10 minus 0, that's just going to leave 14. I'll just put that in, 14. Then I suppose another way of thinking of it as well, if you've got 10 plus 4 makes 14, what else do you need to add on to make 26? So it's going to be 12. Then we'll move on to this cell here. Now this needs to make up to 28, so I'm going to have to put 18 in there. And this cell here, so we've got 22. So actually it's easier just to do 22 minus 22 minus 10. So this is going to be negative 10. So we know this is not an optimal solution because we've got a negative improvement index. But this is going to tell us what the entering cell is. So we write down CY is the entering cell. So we put a theta in that cell, and remember we go back to our last solution that we had, and we now rebalance those cells, remember, using this stepping stone method. Okay, so let's start here where we've got the 13. So I want to keep this column balanced. This has got to be 13 minus theta. The cell under that has got 0, so I can put 0 in. That's balanced. So now down to this cell, let's move across to, I can move across either way actually, so let's move across to this side. That's going to be 10 minus theta. And then the 2 that's over here, that can remain as 2, and that keeps that value, or keeps that row balanced. And then if I go up to this one, I don't need to make any adjustments to this one. There we go. Right, so the largest value that I can make theta to make sure nothing goes negative is actually 0. Yeah, I can only make this 0. Now here I've actually got a cell of 0, and this will become 0. So again, I could choose BY or CY to be the exiting cell, but CY has just become the entering cell, so it doesn't make sense to have it as the exiting cell. So you have BY is the exiting cell. So we'll now put those values in our table here, and then we're going to work out the improved costs as well. So we'll have 13 here, BY is exited, so you have 0 here, 11, 2 and 10, and just make sure that those row and columns add up to the right things. Now if I work out my new improved cost, it's actually not going to change because it's going to be 680 plus the value that I had for theta times by minus 10. So it's basically just going to be negative 10 times by theta. So you can see we haven't improved on the cost yet. So now we're going to calculate our shadow cost. So I've highlighted the cells that we're going to use: 22, 20, 22, 14 and 20. Starting with a source cost of 0, which means this needs to be 22. If that is going to be 22 there, that means that this is going to be 0 as well here. If that's 0, that means that we need 20 at the top here. And what else do we need? This last one here. So if we've got 0, we need 20 at the top, like that. And then that means that this one needs to be negative 6. Now the improvement indices for the unused cells, so this one here, 24, so that means that cell is going to have a value of 4 here. Moving off across to this one, so this one has to be 8. This one here we need to be careful because it's a negative 6, so 26 minus 20 minus minus 6, so that's like the same as adding 6, so that's going to be 12. Watch out for that. And then for this one, 26 minus 22, so that's going to be 4. 4 minus minus 6 is going to be 10. Right, so you'll notice no negative improvement indices. So we know that 680 is optimal, so no negative improvement indices. So we don't need to do the stepping stone method again. So solution is optimal. That basically means that the cost is going to be £680, but we should also state what stock needs to be transferred from what place to another. So starting with the top row of the table here, I'll do this in red. From A to Y, we need to transfer 13 units. So this is part of my solution as well, I guess. From B to Z, 11 units. From C to X, 10 units. 10 units. And then lastly, C to Z, 2 units. So you should now be able to do exercise 1D on pages 26 to 28 of the textbook.